So we start off with a big square here. Nothing fancy. Area is a square, so each side is length a. Small square below has an area of b square, which we remove, so the remaining area is a square minus b square. Observe the two rectangles each having a width b units long from the square which vanished. We can drag the bottom strip up to form a big rectangle. Its length a minus b plus b gives a plus b units. Ta-da! No big deal, right? The difference of squares is a basic algebraic identity. I can bring negative b squared from the left to the right side of the equation like this. Still not a big deal. But this slight algebraic adjustment has the equivalence of embedding a calculator in your head. What if I told you that it's possible to square numbers mentally with this simple trick? Amaze yourself with your superior brain power beyond what a cheap tool can provide. We start with something easy, the squaring of two-digit numbers. Let's try 18 squared. Using the difference of squares, I can express 18 squared minus 2 squared as 18 plus 2 times 18 minus 2. Now, bring minus 2 squared to the right hand side to form plus 2 squared. The algebraic value remains the same. But note now how 18 plus 2 gives 20 and 18 minus 2 gives 16. Are they hard to multiply? If so, ignore the trailing 0. Is 2 times 16 easier instead to give 32? Add back the 0 later to form 320. 320 plus 4 should be straightforward, and before you know it, the sum, which gives 324, is 18 squared. More impressed now? Hopefully not. Let's try something tougher, like 53 squared. I choose to form 53 squared minus 3 squared as 53 plus 3 times 53 minus 3. Why 3 squared? As you can see, 53 minus 3 helps me achieve the nearest multiple of 10, which in this case is 50. Is 56 times 50 difficult to do? If so, simply drop the 0. 56 times 5 gives 280. We can attach the 0 back on later. The last bit of adding 2800 with 9 isn't challenging, and its value of 2809 is the square of 53. A satisfying outcome without requiring a calculator at all. Ready for something more challenging? Let's try squaring 3-digit numbers mentally just for fun. An easy example like 113 squared. You'll believe me shortly. 113 squared minus 13 squared gives 113 plus 13 times 113 minus 13. These are big mouthfuls, but look at how 113 minus 13 gives 100. Add back both zeros after multiplying 126 times 1. Then, add on 13 squared, which in this case is 169. If you can mentally sum up those numbers, 12769 is the square of 113. Incidentally, the skill of ignoring zeros answers the question, what's the secret to this trick? Let's say I ask you to mentally multiply 458 times 5. It will take a while, but if you can hold those digits in your mind long enough, you'll get 2290. Still with me? If so, 500 times 458 won't be a problem. Just add on 2 zeros. The answer is long, but it's not difficult. Anything interesting about 500? Somewhat. It's 479 plus 21, and 458 is 479 minus 21. Observe how 479 and 21 help me achieve the nearest multiple of 100. The square of 21 might take a while to do mentally, but when you get 441, adding that on to your prior 6-digit value isn't too hard. All you need for this trick to work is a basic calculator function, addition. Mentally coding numbers in your head with the correct place value long enough to sum them up. With practice and repetitions, you'll surprise yourself with the extent of perfect squares that you can mentally compute.